the basics of math in machine learning, brought to you by the Machine Learning Math Club. My name is Anna, and I'm thrilled to see so many of you here today. And step by step, other members will join and waiting for our amazing speaker. Before we get started, let's take a moment to get comfortable. This event is not just about learning, but also about building connections. So feel free to use the chat to say hi, share where are you joining us from, or even mention what excites you about today's topic. You can share your LinkedIn profile, share everything you want. It's super friendly community. So let's support each other. Oh, great, from Netherlands and our community, German city, small city, Allen. And let's turn this into a collaborative and interactive experience. So just few minutes waiting for our speaker. He's chatting me. I hope he will join a few minutes. And waiting for him here. And if you want, you can also share your LinkedIn link if you want to make more connections. This will be our first event from series of events. So 1 second, I'll share. Okay. Present mode. I opened, so Ammar, I opened for you present mode. And so we want this session to be as engaging and valuable as possible. So please don't hesitate to ask questions throughout the event. Our speaker, Ammar, I see you're online and even unmuted microphone. Super. So maybe we can hear you. So,
Yeah.
yes, we can hear you. So, okay. And so if you want, we can start. I can stop sharing my screen. And so we incredibly lucky to have Ammar with us, a brilliant presenter who will walk us through the foundational mathematical concepts behind machine learning. This session is perfect for beginners and designed to simplify complex ideas into something easy to understand and relatable. Okay, without further ado, let's give a warm virtual welcome to our speaker, Ammar. Over to you, Ammar. I stop sharing and you can
Okay.
start sharing. So feel free. I open this. Um,
Okay. Thank you so much, Anna, for the splendid introduction. And thank you so much, Google Developers Group, ALA, for inviting me. So it's honestly a pleasure to be here with everyone and all of those who took out their time for this session to understand the mathematical principles behind machine learning. Okay. Before I share any slides, first, we often, understand when we hear machine learning, we go like, is it a superhuman being? Is it a big robot human, right? No, no. Machine learning is very simply just a advanced calculator. It's nothing more than that. Okay? We use machine learning to calculate predictions of data, right? That what is our data going to look like in the upcoming years. Okay? We look at sales revenue in a company, we look at new customers in a company, we even look at, classifying new places for us to sell our products at. All of that nowadays is being used with machine learning. Machine learning is just a series of automatic tasks encoded in one algorithm, right? Previously, we had to functionally program everything one by one for any machine to execute. But machine learning has automated this for us. Yes, a good question by Sayed Shahir. Yes, data analytics is the first step to explore and understand our data. Machine learning helps us take it further into the future. that what is this data going to look like in future scenarios? What new markets can we explore? What new sales will we generate? That comes under machine learning. Understanding what the data right now is showing us is data analytics. Okay, so let me share my screen. Okay, sorry about that. Is my audio a bit buggy?
On my side, everything is perfect. Video and audio is perfect
Okay, okay,
on my side.
okay. It's fine from my end. Okay, okay, no issue. Okay, this is how you guys say it in German, I believe. I wonder if everyone knows this part. Okay, so let me take it on presentation mode now. Okay, developer record slideshow. Here we go.
And
So
I
the
want to
math.
mention that the video will be recorded and shared later on our YouTube channel, so everyone can rewatch it one more time, share with friends, etc. So let's start.
Okay, thank you so much. So first, I'll tell you a bit about what this presentation is going to show you. I'm only showing you a few very commonly used algorithms and the mathematical principles behind them. The logo you see above on the right, okay, the top right, that's actually CourseMon. It's actually my edtech startup, basically, where I'm basically putting in a lot of online course platforms and a lot of offline training institutes in one platform, basically. So yeah, we are going to be changing the dynamics of how online learning and offline learning take place. So I put it in my presentation as well. Okay. So does machine learning equal math? Short answer, okay, is no. Okay. Machine learning is not math. Math is driven in everything, whether it's finance, whether it's HR, whether it's operations. Math is everywhere. So trying to say machine learning is math is like trying to say that finance is economics. They are different things entirely. While machine learning involves math, yes, the logic of math, of basic algebra, statistics, calculus, on how learning algorithms work. Okay. But some one place where I feel universities still don't understand right now is in, like, all of you university students who are on, some here are professionals who have already been to university, or some who never went to university, learned it online. So basically, you all see that most of the tests in university, at least, they, whenever they test you on machine learning, they will make you solve, hey, what is the entropy calculated as decision trees, what is the linear regression best line fit in calculations. If I were to be honest with you, from my experience, the way universities are testing machine learning as an exam is wrong. Because trying to just understand these mathematical nitty gritties of machine learning, but not its logic or how it actually works in a proper data set, you're never going to learn how to deploy it actually. It's basically like us already having the computer, but us still scribing on stones what its calculations are, right? So machine learning is basically created so we don't have to perform manual calculations. Trying to still do manual calculations on it is still like putting the stone on the computer, at least to me. Everyone has the right to have their own opinions on this. Okay. So, how did machine learning start? Arthur Samuel is the one who developed it when he was building a checker playing system. So it could perform its, like, improve its performance by learning the game outcomes. Even though it was coined as machine learning, today we call this system reinforcement learning, where a machine from its own actions and mistakes starts to learn how to perform more more effectively. Okay. So machine learning has been there since 1950s, but we never made it a big deal until after 2015, right? Because every business today is saying we want to improve our business with machine learning, we want to use AI technologies, but very few of them try to understand what it actually is. Okay. AI cannot help work on everything, okay? It can work on things which are already digitally trackable, okay? If I want to say I want to use AI right now, or machine learning model, to improve my sales, okay? I would first have to see if I have a sales database, okay? Where my sales are being retrieved upon. I first have to do data visualization to see what am I learning. Then I will decide what I want to predict further. Trying to apply machine learning directly on just an Excel sheet, it's very poor practice. It's like basically trying to put, what do we say, strawberry on an empty plate of ice cream. It doesn't go with it, right? It's a poor presentation. And I believe people still need to understand that. Build a data team first, then a machine learning team. So now let's look at the most common thing, linear regression. Okay. All of you have probably done this in statistics at some point. So this is the basic formula you can see, right? And I worded it in very easy words. Like when we're calculating the slope, right? We always have to subtract x, the like the feature, the row value with the mean of the column, and then we have to subtract the value of the target row of the target column with the mean of the target column, and then square it, and then divide it by the value of the row in the column which we are dividing it with the mean of it, and then square it. Why do we square in linear regression? To cancel out the negatives. Okay, because sometimes it's very much possible that the value of the row is less than the mean, and that ends up affecting us in aggregating it, right? But we have to aggregate every value's difference, right? So we have to square it to basically negate the subtraction effect on our slope. And when we don't have any slope available, we assume averages, like the mean, the average of the target and the average of the row value. Then based on that, we manage to basically configure what our slope value is next to our the column which we are using in our linear regression to predict the target column. And if we have more than one column, then it will be b1 into x1, then b1 into x2. Okay, we initially assume b naught as 0 because we have to assume that initially there is no slope, but then we have to create a slope and then find out what it initially could have been. Okay, it's basically like completing the cake and then figuring it out how to frost it. And then these are the formulas of cost and gradient. This part, though, I think all of you have already done in 8th and ninth grade math. Cost basically is the error of the machine learning. Gradient is the changes taking place with every new predicted value. Okay, we apply it for every feature column and then weight how much importance we are giving to a particular variable, and we use learning rate multiplied by gradient and minus it by initial weight to get the new weight. Initial weight is assumed to be 0 also as well. Just like we assume the slope, initial slope to be 0, we also assume the initial weight to be 0 when calculating the new weight. Then we find the new weight, then find out what its initial weight could have been. Okay, by multiplying it with the learning rate, which we are usually given based on the scenario at hand. And now we change regression from linear to logistic. It's basically like, converting a car from manual to automatic, because logistic is almost the same thing, except we use the sigmoid function over here to calculate the predictive value, where basically the entire slope of a function of b naught plus b1 into each feature column, it all comes under the Euler's function, because whenever we have to classify anything, right, and we have to check it in two distinct classes in one curve, then basically we have to apply Euler's exponent, basically, because each class is at a very large distance from the previous class, because when the distance is large, we have to assume an exponent. Okay, and we have to divide basically 1 plus e, and then we have to divide it by 1, because we have to see the percentage, okay, that how much it is from its initial self. Okay, that is the mathematical logic, or at least I hope I'm explaining it correctly. If not, I'll be happy to explain it 10 more times. You can put it in the chat. That's not an issue. Okay. And gradient, again, see how it's changing. And then new weight, same formula as linear regression, as you can see. The only difference in logistic over here and linear is only in one thing. Logistic is for classification. Linear is for continuous prediction. Okay. That's the only difference between both of them. I don't sometimes even understand why they call it logistic regression, because look, take a look over here. Whenever we use regression as a term, right, we have to assume continuous change within the slope. But the slope here is constant, because the classes are already divided in two set clusters. So there's no change. Whoever created the statistical algorithm, I don't know what he was really thinking, but I don't really get the point of calling it regression. It should have been logistic classification, to be honest. Okay, so decision trees. Okay, so decision trees is one of the most popular frameworks in machine learning, where we have to split every variable into 3 classes or less to calculate the weighted entropy, like how much effect do they have in the total prediction. Okay, because we always assume over here that that if there are 3 classes, let's say, of a weather, rainy, sunny, dry, and we have to classify the weather based on the other variables we have in our data set. So we have to calculate the entropy, and then we have to see the weighted entropy per feature, that how much each target variable weighs in every feature. And then we see the information gain in decision tree, that how much the entropy of the target is different from the entropy of the feature weighted. And whichever has the highest information gain becomes the feature we need to go with, okay, in decision trees. Now, KNNs, okay? So now normally KNNs, it's the most easy peasy algorithm of machine learning. It's just checking, what is the distance between each data point and square rooting it, because again, to cancel out the negatives, we're just seeing the distance between each neighbor data point and checking which cluster it belongs into. So a lot of people here say that if we have KNNs, why do we have a separate unsupervised algorithm of clustering? Then why do we need that? Because in clustering we assume the data is unlabeled. In KNNs we assume the data is labeled. Okay. Because it's k nearest neighbor, it assumes that there the data is already labeled to find its nearest neighbor. That's why we have k over there, meaning the value at random from the labeled data set. Okay, but in clustering we assume there is no labels attached. Okay, labels as in, like, we don't know that how many sales have there been of Sprite, Coca-Cola, if we never labeled our data set with that which drinks sold were Sprite, which drinks sold were Coca-Cola, which drinks sold were, let's say, Mountain Dew. Then we have to apply clustering because the machine on its own figures it out. Okay, so let me show you a few more things as well. So there's one more thing I was actually working on, which I want to share with you as well, an algorithm on trying to automate the mathematics of a data set. Let me see if I can access that. Basically, a lot of people who don't know basically how to make libraries in Python, it's actually a very easy game. I'll actually show you how you can make it too. Nowadays, now that all of you have Gemini available, it's become much easier now. You just need to feed the logic into your Gemini agent and basically ask it to give you a set of functions for the particular requirements you have. And normally though we use Google Colab. So okay, I'll do it on Google Colab since it's Google's event, I'll have to use their tools. Okay. Okay, but let me search for file, which I believe is in my notebooks. Hold on. Hold on. PS solution clause. Untitled. Hold on. One minute. Maybe I was working on too many notebooks. It got misplaced here somewhere. But there, I'll show you how to use Gemini for it then. Okay, I'll show you. Google Gemini. Okay, the logic you ideally have to feed it is, okay, like example, if I tell you, like, let me give it the logic over here. Give me a set of functions that calculate the mathematical, like, what do we say here? The mathematical nature of the data set, and decide which algorithm to use on it in Python. And then we give it the second prompt, give me the full code as I want to publish this as a library. Okay, I'm already working on something similar, but here I'm showing you how it works. So look, it's automatically given us the entire logic over here. Okay. Okay. So now take a look over here. It's basically placed it all under one date. Okay. Analyze. And look, there's one problem still. It has to put it under one class in order for us to import it as a library. Place this in one class. Okay, we basically say place this in one class. Okay, because in order to publish as a library, we have to do that part. Okay, so now it's copied. So now let's show it. And okay, so now let's go over here to collab. Okay, now let's run it. Okay, let's run it to see if it works. First, let's test on collab if this entire class is working, because it often comes with a lot of errors. We have to keep checking in every now and then. Happens with me the most. Okay. Yeah. Okay. So let me save this as maths L. Okay. Okay. Maths L, it's been saved as. Okay. So now if I want to, like, let's say import it, now watch this. So in my Jupyter notebooks over here, Collab doesn't have this feature, unfortunately, right now. So we'll have to use Jupyter for this. Okay. So if I need to first check, let's go to downloads over here where I probably downloaded this. Okay. mathsl.py saved here. So now let's go to new Python 3 and let's click on import maths L. Okay, see, now my library has been imported. This is just an example. Okay, and again, this is not a library because you have to publish it in PyPy in order to use it as a proper library. This is just an example sample of this. Okay, now let me answer a few more questions now without slides, because look, I'm the kind of person who honestly believes that I want to have the discussion to be more engaging, because I feel that, slides normally don't give people the full picture. Okay, if you actually work in some companies, some of them don't prefer using slides either. So now let's talk about what machine learning actually is. Why is it important? When is it important to use? When is it not? So I'll be honest with you, a lot of people make this mistake. They don't clean the data set, they don't understand the business logic, they directly start applying machine learning into the data set, and they end up spending so much time, so much computing resources, because people think it's just doing Jupyter notebooks. No. When you're doing actual data work, right, then your data is not in gigabytes or megabytes, it's in terabytes. Google's data alone is like 5 terabytes per second. It's a lot of data, right? So imagine you working at companies at a large corporate level. So you can easily expect data to be easily 500 gigabytes. That's basically the size of any laptop's total storage. When you're running that, machine learning takes a lot of time to work on a local machine. So we end up using cloud services to buy more computing power to run the algorithm faster, or buy more computing storage to run the algorithm, to store our data. Okay. So all of that in computing resources easily on an average estimate comes up to a good $10,000 on a, and I'm lowballing it over here. $10,000 is a low ball. It usually goes far more when it comes to more data and more computing resources, depending on which services you're using. So if you haven't even explored what the business logic is, what the data is, and directly start investing so much money, your money will have been wasted for nothing. Okay, because people, and please be friendly, please do not put such comments on the place. Okay, so basically now people usually think that, hey, we have a $10,000 worth of a solution, they think it's going to have value. No, that's not the case at all. Your value of the solution lies in how well you can explain it to the clients and the stakeholders, because end of the day, people only invest in what they can understand, right? If you told them that I built an amazing computer vision model which can even, that can detect cars which are not even available in most countries, then they can easily reply back to you and say, like, if those cars aren't available in most countries, why do we need a classification model to detect them, right? There's no business logic to use that model. But if you can say that those cars are being trafficked all over the world and we can sell this model to securities, to security agencies, then they'll be like, okay, that's $1 billion market. Then we can buy this model. So the entire concept of machine learning data analytics comes down to its commercial value. So before ever engaging into data science or machine learning project, commercial value of your project. Okay. And thank you, Anna, for saying that. Okay. So, and furthermore, like I also feel like a lot of people have also been questioning me that tell us, Ammar, that we want to do masters in machine learning, masters in data science, masters in data analytics. Which one do we do? Well, I honestly tell you that it all depends on what you like. Data analytics is most for people who are good storytellers. They're people who hate doing maths, but they love telling stories about math. So if that's your goal and that's your hobby, go for data analytics as a good master's program. In business analytics or data, they are interchangeable terms. It doesn't make a difference. But if you really like drilling down into advanced computing tools, advanced programming, like a bit of it, then data science, a master's is a good job, because most of the master and data science programs, they make you build models on random data, which is normally not even available in some places. Like when I was doing my final project for my master's in a data science scenario, I took a very unique topic, because in universities, they always have to choose a unique topic, right? They don't let you replicate existing ones. You have to, or even if you're replicating it, you have to find a unique angle to it. So the topic I chose was Islamic banking machine learning predictions, to try and apply machine learning predictions on Islamic banking operations, because I felt no one does that in the world. So I blindly chose a topic and had no data for it. And then obviously when my task came to finally get the data, I didn't know where to get it from. So what I did was, basically I found that there are reports published on Islamic banking operations worldwide by particular organizations like Islamic Foundation, Islamic Banking, and all that. So I basically took one of their financial reports and manually converted it into a data set and then put it into the machine learning algorithm, right? I manually did all that work, but it worked. And I luckily got a distinction in my project just for doing that, because no one else did it in the world up till now. So yeah. So sometimes when there's no data available, that doesn't mean you can't find the solution. You just have to create the data using logic. Example, let's say in our country, let's say in developing countries, we don't have technology for monitoring environmental conditions, but we have people with good memories over there who remember the environmental conditions each and every time. So you document what they know and then build a data set with it. It's very possible. Obviously accuracy is not the same, but if I'm being honest, as a data scientist, there is no such thing as 100% accuracy in any machine learning model, because no matter how good your model is, how accurate it is, there's always a chance for error. But once you build your first model, it becomes easier to improve the accuracy with time as you get more data in it. Because when Netflix built a recommendation engine model, Amazon Prime built it, initially it yielded very bad results, like 30% accuracy or even 20%. Sometimes when I was checking for a new horror movie, I'd get a fairy tale movie instead, because the recommendations were wrong, right? But over time, as I started collecting my data and started checking my preferences, then it started giving me accurate recommendations. So any machine learning project, if it's not good at start, doesn't mean it's not going to be good over time. So these are the logics you need to always understand. It's a model that is learning, not a model that knows. That's why we call it machine learning, not machine knows. Okay. So with that, that's the conclusion of my session. If you have any question and answers, I'll be happy to answer them.
So as I can see, we have questions in chat, but maybe I can. It's not a question. Someone last question. Okay, and from my side, it will be just like asking your advice. What better to use for practicing? Because I understand for machine learning, we don't need so a lot mathematics, but of course, someone need to refresh knowledge from universities, or someone just start this journey, and maybe you can give this advice. And let's back to question. So how would you know at the beginning the model has the potential to grow into a good model? Oh, good
Okay.
question.
So that's a good question. Okay. To be very honest, there is no right answer to that, because basically every model at start doesn't have a good trajectory. Over time, as we improve the model, then we know that the trajectory is proper. Okay. That's basically how you first, but you have to identify, is there any commercial value to creating this model? That's what you need to always remember. Over time, if the accuracy is not good at start, it will be good over time. That's basically my answer to the question. And would you mind explaining decision trees again? Okay, decision trees basically are how multiple variables might cause a single outcome. That if it's sunny, if the temperature is this much, if the moisture is this much, will it rain or not? The three variables connected together give what answer? That is a decision tree. Hope that answers it. With a lot of distinct meaningful values. How to make use of this high cardinality field in my prediction system, basic set of possible categorical labels for headlines. There are a lot of them. Okay, so in your case scenario where the model, like there is a lot of distinct values, right? Model will not be able to give you the good answer you're looking for. Like, but what actually can do is provide scalability to those distinct values. Okay, because when you provide scalability, machines are able to learn better. Because I had the same problem with another a data set of education as well, when I wanted to predict in number of enrollments in my education system. So it had a lot of distinct values as well. So what we did, we scaled the model. So then from accuracy to 10%, it came to 40%. So for a high cardinality data set, that is actually a big achievement, because you can never cross 30% of best fit or accuracy in that. Okay. Yeah, and thank you. I'm glad everyone liked it. And everyone, I believe Anna has my LinkedIn profile as well. If any of you want to connect with me on LinkedIn and take advice on any university or any matter or a course or training matter points, you can always reach out to me. I'm happy to help anyone in the same journey as me.
I just tried quickly to share, uh, mentioned about decision tree. So I like this from Free Code Camp. It's not a short
Yeah.
video, it's more than 1 hour, but with good explanation. So if you want to
Yeah.
dive deeper and understand very well
Thanks,
decision
Anna.
tree, so this is very good video to write.
Thank you.
So, and if it's possible, I can share your LinkedIn profile here, if you want.
Yeah, please do. Please do.
Uh, and one more time, I honor that you find time, because I know that you speaker or courses creator, and you're super
No.
busy, but you find time
No.
to start this series of events. And I hope we see you in our Google
Soon, inshallah.
Developer Group Allen later. So,
Yeah.
okay,
Inshallah soon.
any
And it's okay.
questions?
I never say no to any help to students.
Okay, any questions?
I think a lot of them already asked so many.
So, okay, let's give a huge round of applause to our incredible speaker, Ammar, and for delivering such an
Thank you, everyone.
insightful and really engaging section. So, thank you, Ammar, for making the foundations concepts. It's a good start for us of math and machine learning. And of course, heartfelt thanks to you all, our amazing audience, for joining us today. Your enthusiasm, participation, and questions truly made this event special. I have some great news for those of you who want to revisit today's session or share it with friends
Mhm.
and colleagues. This session was recorded and will be uploaded it to our YouTube channel soon. So stay tuned. I'll share it on LinkedIn also. And if you are not already part of our Machine Learning Mass Club, we would love for you to join our community. So we have many exciting events planned, and we'd love to see you here. Also, your feedback is so important to us, so please let us know what you thought about today's session, what you learned, and how we can improve for the future. It helps us create even better experience for you. Thank you all for being here today. Until next time, keep learning, keep keep exploring, and we'll see you at the next events. Take care and goodbye for now.
Okay, thank you. Bye.